A definite interval. Let's see how that, and we'll do it with the C value as well. So let's go 0 to 3 of this little function called x to the third power minus 6x dx. We'll do it real quickly before Zachariah comes back. Oh, never mind. Okay, doing this process here, we want to be able to do the antiderivative. This is power rule, so we know this stuff. And let's see, we're going to put the C inside it. I want to see for us to know what happens to the C value. Okay, so you guys talk to me here. Oh, I get to pick on people. That's right. Zachariah. Actually, no, you just came back. Haley. Antiderivative of x to the third. Perfecto. Right, you just add 1 to the exponent, divide by that number. We're good there? So Nicholas, all yours here, adding 1 to the exponent, divide by that number. Perfecto, yeah, and then divide by 2. So we're going to put a plus C in here because we want to see what happens. And then we're just going to evaluate it from 0 to 3. Okay, put it like that. And your book actually does it like this right here, just evaluation process. At the end, they don't even do the. So let me simplify this real quickly first. X to the fourth over that. 6 over 2 really is just 3. So let's just write 3x in here. There's your simplified form. Oh, sorry, I forgot my C value. Plus C, 0 to 3. And this is going to be the funky one, right? Afterwards, we're going to be doing it easily. All right, let's plug in a 3 here. 3 goes into that one. So this would be 3 to the fourth divided by 4 minus 3 times 3 squared plus C. And I'm going to put this all in parentheses here, minus. And this is where we learn to love zeros. Three times 3 times 3 times 3. Zechariah, 3 to the fourth power. Try to get you. Couldn't get you. 81 over that minus 3 times 3. I'll do the 27 plus C. Then all this goes away, huh? That's all zeros except for this little minus C. So what happens to the C's? They cancel each other out. So we're not going to put C's anymore. Ain't worth it. So those get crossed out. And then let's see, anybody? 27 with the denominator of 4. So, oh, Haley, it's your turn here. Common denominators. And if you guys need a calculator, go for it here. I need a common denominator of 4. 4 into 27. Or 4 times 27. 108. 108. And now we need a subtraction off of that. So Haley, you're going to be our calculator operator. Unless others brought their calculators with them here. Negative 20. Oh, it is negative 20. Okay, so negative 27 fourths. You can write negative 6 3/4. You can write negative 6.35 or 75, whatever. It doesn't matter as long as you guys get to that answer there. We're good. Okay, so now let's go with it here. Now table. Good. You guys tell me if I'm going too fast. Very good. Okay, now let's draw our attention to page 392. And you have these table of values here. So the first 1, 2, 3 on top, those are just general rules. That means you can stick a c out of the, if it's a constant, you can take it out. You can add things together, or you can split off the integrals. That's fine. And then if you have a k value, just a regular old k by itself, then that means you have an x next to it here. So let me rewrite those just so this is what we're talking about here. So there it is. If you have a constant that's multiplying a function, these are just very general rules here. You can take that out and just deal with the function itself. That's cool. All right, if you have two functions, which we just did, right? We handled each of those as two distinct functions real quickly here, because Haley did one and Nicholas did the other. So there it is. We can split this off just to make it a little easier and then just do them individually. And that sometimes would help as well. Okay, and then if you have just a k value, just a constant all by itself, I'm not sure why they didn't use a little c, maybe just because it confused little c and big C maybe. But k being a constant, it just means you're going to have this little x. Okay, so these are guys are called still indefinite integrals because there's no numbers next to them, right? So we always put c value. We do see numbers next to it. Forget the c value because they're going to cancel anyways. Okay, let's jam. So the rest of them, going all the way down the list, 1, 2, 3, 4, 5, 6, 7. So 14 of those. All they did is they took the derivative. Right? So let's do one just to make sure. So they say, okay, let's do this here. Let's go with yeah. So if you go like this, take the derivative of sine. We're going to reverse engineer all this here, guys. Oh, sorry. Well, all yours here. What is the derivative of sine? Let's see. Zachariah, I haven't picked on you yet. Go ahead. Cosine. Okay, so then the table on the list is, okay, that means the antiderivative of cosine will be sine. And then we just need to add the little x. So it's all the derivatives that we've done so far in reverse. Okay. And so we've studied power rule. Yes. We've studied the ln function. Yes. We've studied the power function. Yes. E to the x function, all the trig functions, and the hyperbolic trig functions, and the inverse trig functions. All those are there. We've got so far 14. Okay. I will tell you, second semester calculus, part of the class, like half the class, is to develop more and more of these rules. So half the class is the whole class is dealing with antiderivative because we need to develop so many more rules. It's not like the derivative where we took half a year, like, hey, we got it all. That was cool. That was the small piece. Antiderivatives is the big, humongous piece that starts off because there's so much applications to things. Okay, with that said, notice a few things here. We should notice when you take the derivative of secant. So let's do one more. No, not the antiderivative. Oh, reach all the way back, guys. Do you guys remember what is the derivative of secant? Arno. If I remember correctly, it was, oh yeah, we got some derivative rules in the back, huh? Derivative secant. Awesome. Secant x multiplied by tangent x. Cool. Okay, so if we go the other way, notice we're going to go, what is the antiderivative of a secant x multiplied by tangent x dx? It's going to be back up to secant plus c. Good there? So the antiderivatives are actually kind of funky in the fact that we don't have the antiderivatives of all the trig functions. We have it for cosine, we have it for sine, but we don't have this one. Antiderivative of secant x dx. Because if you look at all our derivative rules, right? All the derivative rules that we have is we did take the derivative of all the trig functions, but there's no something that actually gets you to secant. Now there is one, it's secant squared. The derivative of tangent is secant squared. Therefore, the antiderivative of secant squared is tangent. I got that one, but not secant by itself. We're good? So we're kind of missing. There's so much gaps in here. Okay. With that intro, let's jam. We're on exercise 2, and we're just going to do a whole bunch of these. Let's see. We can do the integrals. Cool. And let's jam. Let's practice here, because it's just about indefinite integral and definite integral. We're just gonna practice with a whole bunch of them like that. So A, and give you guys a little bit of time to try it yourself, and then we'll go from there. I need the antiderivative from 0 to 2 of 2x cubed minus 6x, and then of course I'm going to throw in a fun one for you. All right, we're going to start off slow a little bit, and by the time you guys are finished with the day, you guys will be jamming so fast. This stuff will be so easy. Lots of practice with this stuff. All right, and let's go with it here. So back to Haley. All right, undo for me 2x cubed.
Is 2x.
Awesome. 2x to the 4th over 4. Awesome. Nicholas, the same exact. Yeah, same exact number.
Yeah, it's still x, or 6x squared divided by 2.
And of course, I'm going to throw in the monkey wrench for Zachariah. Zachariah, all yours. 3 over x squared plus 3 plus 1. Yes, if you look at your list here, the integral of 1 over x squared plus 1 dx, which is just really that 3 is a multiplier, right, is going to be tangent inverse of x. And then from here, we're evaluating from 0 to 2. Okay, simplified form, just so we can have a simplified version of this stuff here. So I got x to the 4th over 2, that's simplified, minus 3x squared, and plus 3, yeah, it is an inverse here. Inverse of x, 0 to 2. Wow, crazy stuff. Okay, let's see. Zeros are our friends. And let's go from there. Let's see what we get out of it here. So I'm running out of room here. So I'm going to go plug in a 0 into there, plug in a 2 into there. 2, was that 16, I believe, is that right? 16 over 2 is 8. I'm going to switch back and forth between these guys here. So I got myself, I think it's 8. You guys have to help me out here. That's going to be 2 squared is 4 minus 12. And then we have this plus 3 tangent inverse of 2. Whoa, that's fun. Okay, then minus, in this case, because we have those parentheses, I'm going to put this into bracket form. Okay, so let's see, plug it in here, 0, 0. Okay, I got 0, minus 0. And then this one, let's talk about it here. It's plus 3 tangent inverse of 0. So you guys tell me here, what is tangent inverse of 0? It's 0. I think so. If you look back on your unit circle and you say to yourself, when is tangent going to be 0? It's like right here. It's when this guy is 1, 0. So tangent is y over x. Therefore, tangent is that one right there. No, tangent, sorry. Let me write this correctly here. Tangent theta is y over x. Therefore, theta, whatever theta is going to be, it's going to be a 1 over 0, and that actually happens at theta equals 0. 0 degrees, but 0 radians in this point. All right, will your calculator do this? Absolutely. Click in tangent inverse of 0, it'll give you 0. So that becomes 0, 0, 0, 0, 0. And final answer, anyone? It's still Monday, it's okay. I got myself, that's the answer. All right, if you want to put it in a calculator, let's do that here. If you have your calculators out, can you punch this into your calculator? Give me 4 decimal place accuracy of this thing. So what's -3 times -4 plus 3 times tangent inverse of 2? So I'm going to put these little wavy signs. That means approximately.
186.
Ooh, ouch. Okay, let's do this here. Let's go make sure you guys are in radian measurement on your calculator, because almost always we're in radian measurement. Very rarely do we have degree measurements things here. .06.
Yeah, 6, 7, 8.
7, 8, 4 decimal places.
6.
That's it. Okay, 8, 6. Cool. See if you guys get that right. Good one now. Cool. So there. Whoa, hold on. It's actually negative. How crazy is that? Hold on. We're trying to get area underneath the curve. We get a negative value. So let's see what's going on here. So I'm going to go like this. And the curve that we're looking at goes like this. It starts off at 3. And it goes down like this. Then it swings up like that. And this is from 0 to 2. So 2 is like right here. All right, you guys talk to me. What's happening? We get a slightly negative area. Or you may not want to talk to me. That's fine too. So I think what's happening is this little area right here is positive. This area right here is positive. And I'm going to do a light. And this area here is negative. And so when you add up all the areas together, the area that's negative beats out the positive area together just by a little bit here. All right. Okay, so positive here, positive there, negative there. Cumulatively, it's still negative. Okay, let's jam B. Do a whole bunch before class is over. Okay, that was a good one. Okay, let's do some tricks here. Tricks of the trade. 1 to 9 of, And of course, switch variables on you. I mean, I'm going to do a whole bunch of good stuff here. Cool. Okay. And then 5.5, we're going to learn one little extra trick in the process. That's all. All right. Yeah. Let's see. Think back to your algebra days. How could you simplify this? Especially understanding there's only one term in your denominator. I can sing Jeopardy. Dun, dun, dun. Yeah, we can cancel it. We can actually write the t squared underneath each one of the terms, right? Because that's the thing that we have is if you have a single term in your denominator, you can divide each of the pieces by that denominator. And you can do it in your head and real quick here. If you want to show it so that you know what you're doing, then we go like this. We go 1 to 9. And we say to ourselves, you know what's going to happen is that's going to happen. This one we probably need parentheses now at this point. Ooh, this one, you guys, we'll deal with it in just a second here. That's a square root inside there and squares. Wow. Okay, I'm thinking something like that. Is that right? Okay, simplified form, like equal signs here, even equal signs. 1 to 9. Oh, this is nice. That's just a 2. That's just a square root of x because the t squares cancel, huh? So real quick here for calculus sake, let's do this here. We're just going to write it as 1/2. Just be easier to do stuff with later on. And this guy, I don't know, we can bring it up to the top because we don't have fractions, all those. So let's do this, t to the -2 dt. All yours. 30 seconds. Can you guys give me the antiderivative formula? Okay, antiderivative of, and let's see, who should I pick first? Nicholas, all yours. Antiderivative of 2.
Just 2.
2, and then we've got the little multiplier of our variable. All right, so I'm thinking just the 2t, right? It's the constant term, and then you just tack on the variable at that point. Good. Zechariah, all yours. T to the 1/2.
T are 3/2 divided by 3/2.
Awesome. T to the 3/2 divided by 3/2. Okay, and then we'll do this real quick here. Let's do this right now. We'll do this kind of faster. If you have fractions there, all we do is we just take the reciprocal and we're good to go. So we have that right here. But then what we do is we just say to ourselves, okay, that's going to happen, but it's going to be 2/3. Just take the reciprocal and multiply. Just a lot easier to deal with that than on it, because we're going to have those a lot. Okay, and Haley, t to the -2. Ooh, close. Go in the wrong direction. Go the other way. Absolutely. T to the -1 over -1. And all that is evaluated from 1 to 9. Shucks, no zeros here. That's no fun. Okay, let's jam with this. So the only thing I'm gonna just quickly do this little piece right here. Let's see, do we need to do this? That's gonna be the cube root of t squared. If you need to do that, just kind of bring it back into that one. I'm going to put a plus sign here. Is that okay? That's 1 over t. Okay, everybody okay with all those pieces there? Cool. All right, let's plug in some 9s. Let's plug in some 1s and let's see what happens here. So you guys do it yours. I'll do mine. And let's see if we come up with the same answer. I got myself 18. Sorry, class. I messed up here real quick here. 1 second. This should have been a square root of cubed, right? It's the cubed and the square root. It's the denominator becomes the index for the root, and the numerator becomes your power out of it. So that'll be a fun one. 9 times 9 times 9. Anybody got that? Just get for 9 times 9 times 9, and then take the square root of that. Second? 27. Oh, okay, cool. 27 divided by 3 is 9. 9 times 2 is 18. Okay, thank you, sir. Okay, then we got ourselves a 1/9 over here. Minus. Now we're plugging in a 1. Okay, I like 1s as well. 1s are pretty cool. And 1 over 1 is just 1. Okay, got some work ahead of us though. So I probably will put what? I'll probably put all the. This will be 36 plus 1/9. Subtracting off 3 and 2/3. I don't know if you guys want to do it individually in each parenthesis and then add it together. That's fine. Some people just kind of like get rid of all the parentheses and then just do it from there. You have to deal with the 1/9 anyways here. So I'm going to get rid of all the parentheses and then just deal with that. So 36 plus 1/9 minus 3 minus 2/3. Let's get everything denominators of 9. The big one will be that 36 though. So 9, 9 plus plus minus minus. So 9, 9, 9, 9. Okay, I'm going to go back to my. Okay, anybody 36 now with a denominator of 9? $324. Sweet. Got a 1 on top of this guy. I got a 27 here. Is that right? 27 for that. And times 3 will be a -6. Okay. Okay, and then all yours to add those guys up. 324 plus 1 more, minus 27 minus. Ooh, this is a -6. Hold on 1 second. I wrote down a -6 now, it's just a 6. All right, give that to me. What do you guys say?
Is 32.4.
Oh, gotcha. Oh, what's just the top? What's 324 plus 1 minus 27 minus 6?
Is that
292? 292. Anybody second that?
Yeah.
292. And let's see. And then Haley divided this and we got 32.4444 repeating. Okay, so if that's the case, then you also know that this is really 32 4/9 because the 9 gives you a repeater of that same value. Okay, and we have maybe time for one more here. And again, they'd be kind of tricky a little bit like that. So you gotta have to think about, okay, how can I undo this, right? How can I undo it? Now we're gonna get just one level up on 5.5. Okay, let's do exercise, just to give you one that does not have numbers to plug in here. Just find the general indefinite integral. Here it is. And tricky one, of course, give you a tricky one. Let's see. I'm going to say A. If we have time for B, we'll do B. But here it is. All right, a d theta on our hands here. So if we get to B, that's fine. If not, that's fine too. Okay, so look at your chart. Dun, 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 and you're trying to figure out, how can I fit that into a chart that I know on page 392? What the heck? So I noticed that there's a sine, there's two sines, right? There's sine squared on the bottom. Now that's kind of what I noticed. So off to the side, maybe I'm thinking to myself, okay, hold on. I could split this off maybe into something that looks like this. So 1 over sine minus cosine over sine. So I'm just guessing here. That's all. I'm just guessing. In my mind, I'm thinking this because of sine squared on the bottom. And does that get me anything here? Well, let's see. 1 over sine. What's over 1 over sine? Anybody from trig class last year? I know it's been last year, but I think you guys can still have. Cosecant. Okay, and then cosine over sine. Cosine over sine, cosine over sine. Cotangent. Okay, so now I think that kind of gets, okay, so do we have anything that's sort of close to that in our little list over here? Yep, perfecto. So this guy now changes into cosecant theta times cotangent theta d theta. That's cool. We don't have any numbers to deal with, so we just need the antiderivative of it. So what derivative causes it to be a secant x cotangent x? It's negative cosecant, oh, and theta. I was concentrating on it and made my own mistake. Okay, are we good there? So we're going back off the list. We matched it. It's the third from the bottom on the right-hand side of our list. Cosecant x, cotangent x dx, and in case ours is a theta instead of x, that's fine. Let's put a little plus c. Boom, and we are done. And I think we covered everything. Guys, so all it is, just a little bit of algebra, kind of thinking through how am I going to do this process, and then go for it. Yes, you can cancel stuff, split denominators if you need to. Just kind of use all the algebra techniques to get you into the form that you can work with. With that, let's finish class early, like 20 seconds early. All right, you guys have a good Monday.